Hi, I'm Eva Murphy from Electronic Engineering at IT Sligo, and this is my Leaving Cert Maths Grinds channel. I'll regularly add new videos for both higher and ordinary level maths, so make sure you subscribe below and click the bell icon to be notified of new videos. Right, let's have a look at this one. The product of the first three terms of a geometric sequence is 216, and their sum is 21. Given that the common ratio or is less than 1, find the first three terms of the sequence. So again, just like before, we're going to use, back to the theory page, we're going to use the general form of the sequence. Okay, so we know that the general form of any geometric sequence is AR squared, AR cubed, and so on and so forth. So in this question, we were concerned with the first three terms. So therefore, so the product of the first three terms, so we know that A by AR by AR squared is equal to 216. And we also know that A plus AR squared was equal to 21. Okay, so they were the two pieces of information that they gave us. Okay, now I'm going to do it the wrong way first, or a harder way first, to show you what would normally be done. So when you say product, you're multiplying these. So let's multiply these. So A by A is A cubed, or by R squared is R cubed equal to 216. And here we're adding them. So not a whole lot you can do. Something like that being equal to 21. Okay. And it would be nice, for example, to be able to write this in terms of A and sub the A in here, like we would simultaneous equations. So in other words, A cubed was equal to 216 over R cubed, or A is equal to 3 root 216 over R cubed. And then sub them in here on 1 plus R squared equal to 21. And then with a lot of computation, you would be able to work this out. Let me see, is there a 3 root 216, an easy 3 root 216? Yeah, there's 6 over R times 1 plus R squared there being equal to 21. And then mess around with it, and it's very solvable. Okay, so that is one way of doing it. Isolate one of the equations in terms of a letter and then sub into the other one. Okay, so it's like simultaneous equations with the x squared and the y squared into it. Okay, now there's another way of doing this that I just want to show you for something different. And it's as follows, okay? Let's divide across here by R. And let me show you what happens. So the first term then becomes A over R. The second term becomes A. And the third term becomes AR. Okay, and it's again equal to 216. Okay, so all we've done is literally divided our first three terms by R. Okay, why did I do this, I suppose? Well, let's now multiply the three terms together, and I'll have A by A still equal to A cubed, but this time the R cancels. Okay, so I end up having A cubed equal to 216. Okay, and then therefore A is equal to 3 root 216, which is equal to 6. Okay, so that's one way of finding A. Now, if I'm going to divide the three terms by or in this equation or in this piece of information, then I have to do the same here, okay? I can't just go back to the original terms here and let that equal to 21, whereas when I divided by or equal to 216. So in other words, it's keeping the proportion or the ratio the same. I made this one or times smaller, so I have to make this sequence or times smaller. Okay, and then I can compare the two. So let's fill in our sixes that we have. So I have 6 over or plus 6 or now being equal to 21. Okay, so what are we going to do here now? Well, we need to get or a common denominator if you want to look at it like that. So that I end up with 6 plus 6r plus 6r squared being equal to 21r. Okay, so I hope that makes sense. I've got a common denominator of or, and if you think like fractions, that will make perfect sense to you. Maybe you don't think of fractions, maybe you multiply across by or, whichever way you think of that. Why do I have to do that? You always have to do that when you're adding and subtracting fractions. Okay, so now I can drop the or because they're all over or, and you can see this is starting to look like some sort of quadratic, so that I end up with 6r squared plus 6r minus the 21r plus 6 being equal to 0. So I just brought that 21r over here, and I have 6r squared then plus 6 minus 21 is minus 15r plus 6 being equal to 0. And it's up to you at what you do at this stage. You can minus b it, you can factorize it, you can do whatever you want. I'm going to minus b it in case anybody can't see the factors. Okay, if I was factorizing, I would have definitely divide across by 3 just to make the numbers much smaller. So a is 6, b is minus 15, and c is 6. So we know that, well, the log tables says x, but this is or. So or equals minus b plus or minus square root of b squared minus 4ac all over 2a. So even though the log table says x, that's because most quadratics are x, but what you're actually solving for is the letter in your question. So it's good practice to start writing that letter down here so that you know when you solve it, you know what you've solved it for. So minus b, so minus 15 plus or minus the square root of minus 15 squared minus 4ac all over 2 times a. So minus 15 is 15. Right, let me put the square root bit into a calculator. Minus 4ac, and I've got 9 all over 2 6s are 12. Okay, so let's split it then. So my first answer is 15 plus 9 over 12. And my second answer will come from 15 minus 9 over 12. So you split the plus and minus. So hit the fraction button first. And in this one, I've got r is equal to 2. And in the other one, I'm going to get a minus answer, which is equal to a half. Okay, so there are my two answers. There are my two possible common ratios, a half or 2. So I have to come back to my question again to see if have I got more information over what the common ratio should be. And it says here in it, given that the common ratio is less than 1. Okay, so therefore, if r is less than 1, then or equal to a half is my answer for this particular question. Okay, and then it says find the first three terms of the sequence. Well, again, I'm going to use these three terms in the general form here. So A, AR, and AR squared in theory, and then we divided them across by R. Where am I? A over R, A and AR is what I'm trying to write here. Okay, so they are the three terms of my sequence that I have to use. Why am I using them and not these ones? Well, when I was solving for my A and my R, I did it with respect to a sequence that was R times smaller. Okay, so at all times I used A over R, A and AR. I used it here to find my R. So therefore, to keep the proper ratio together, I need to use that when I'm writing out my actual sequence. So A over R, what was my A again? My A was 6. Was 6 over a half, 6 times a half. I did that before. Okay, so 6 over a half then will work out to be 12. 6 and then 6 times a half. So the three first terms in this sequence are 12, 6, and 3. If you've enjoyed this video, then why not join us in IT Sligo and use maths in practice. In conjunction with industry, we've designed an exciting new program in electronics and self-driving technologies, which uses cutting-edge techniques such as artificial intelligence, computer vision, and virtual and augmented reality. You'll need a H5 in maths to qualify. Check out the link below.